Yesterday we talked about derivatives of logarithmic functions. Today we're going to be diving into integrating logarithmic functions, and you should be able to integrate quite a few before this lesson is over. So, first of all, the derivative of ln of x and the absolute values are there because we know anything inside of a logarithm must be positive is 1 over x. So, that means that when we integrate, the integral of 1 over x dx is equal to the ln of x plus c. Also, a little reminder here, for all log functions, we can use the change of base formula to change to ln in all cases. So keep that in mind. We can write log base 3 of x as ln of x or ln of 3, which might come in handy. So let's try one. It says find the area under the region. Find the area of the region under the hyperbola xy equals 1 from 1 to 2. So, if xy equals 1, y equals 1 over x. So we need the integral from 1 to 2 of 1 over x dx. If you need the picture for that, do it. Otherwise, let's anti-derive. The antiderivative of 1 over x is ln of x from 1 to 2, which means we use the ln of 2 minus the ln of 1. Couple options here. You could know that the ln of 1 is 0, or we could combine these by division, however you want to go about it, and find out that this equals ln of 2, which is approximately 0.693147. Next example, we've got x over x squared plus 1. And we need to be careful because we don't directly know the antiderivative of x over x squared plus 1, so we're most likely going to have to do some u substitution. We make our u x squared plus 1, du dx is 2x, which means du over 2x is equal to dx. So let's plug in what we know. Got our x in the numerator, our u at the bottom. Dx is equal to du over 2x. If you notice, these x's will cancel. I can pull the 2 out front as a 1/2, and I've got 1 over u du in my integral. Anti-deriving 1 over u du is not tricky. We just get ln of u plus c because we don't have endpoints. We can't leave our u, so we have to rewrite it. Ln of x squared plus 1 plus c. With the 1/2 out front, we could also move that power up and write it as ln of radical x squared plus 1 plus c, because x squared plus 1 to the 1/2 is the same thing as a radical. So there's another option. Next example, they want us to evaluate this without a calculator. Right now, in its current state, it appears as if we do not know what its antiderivative is, which means we're probably going to have to use some u substitution. What we need to decide is what should we make our u. It is pointless to ever make u something whose derivative is 1, so that rules out our x in our denominator. So we should probably use our u as ln of x, which means du dx is 1 over x. Cross multiply x du equals dx. So if I plug in what I know, we have u over x times x du. My x's will cancel, so I've got the integral from 1 to e of u du, which, when I anti-derive that, I get 1/2 u squared from 1 to e, or 1/2 ln of x squared from 1 to e, which means 1/2 ln of e squared minus 1/2 ln of 1 squared. Ln of 1 is 0, so that goes away. Ln of e is 1. 1 squared is 1 times 1/2 is 1/2 as our answer. On the back, we're going to learn one more antiderivative. If you remember from our previous note, the derivative of a to the x was the same as a to the x ln of a, which means the derivative of a to the x dx is equal to a to the x over ln of a plus c. The ln of a is a constant, so it could be divided there. So let's try a couple. The derivative of 2 to the x, you look back up at that formula, or the integral of 2 to the x, look back up at that formula, we know that it is 2 to the x over ln of 2 plus c. Keep in mind, you would have to multiply by the derivative of that x if it was anything other than x. X's derivative is 1, which is why we don't need to worry about it in this case. This next integral is a little tough. I don't really know anything whose derivative is x to the 5th plus 5x altogether, but I'm going to break this up. And I'm going to get 1/6 x to the 6th plus 5x, sorry, not 5x, plus 5 to the x all over ln of 5 plus c. And I only need 1 plus c because they would both have of them, but a constant plus a constant is just a constant. So those will cancel out. Look this over, watch it again if you need to. Make sure you are ready to dive into problems when you get to class tomorrow.